Hello students, welcome back to Education Fingertips. Today we are going to solve 9709 5 to FM 22. Let's get started. Question number 1. A fair red spinner has edges numbered 1, 2, 2, 3. A fair blue spinner has edges numbered -3, -2, -1 and -1. Each spinner is spun once and the number on the edge on which each spinner lands is noted. Okay. The random variable x denotes the sum of resulting two numbers. Okay. So what we do? We have two spinners. We note down the numbers on which it lands and then we add the results. Draw the probability distribution table of x. Okay. Let us draw probability distribution table. So for probability distribution table, we first need to know the possible outcomes. Right? Let us find out. Let's say this is my event x and this is my probability of x. So I have 1 and -3. I think -2 is possible. 1 and -2, -1 is possible. 1 and -1, 0 is possible. 2 and -3, okay, sorry. 3 and -2, 1 is possible. 3 and 1, 2 is also possible. Okay, so these are the different number of outcomes which are possible. Now let us find out probability of each of the outcome. So probability of getting 2, right? How can you get 2? If you have 3 on red spinner and 2 on blue spinner. So this is 1 by 4 into 1 by 4, 1 by 16. Easy. Now let us find out probability of getting -1. In order to get -1, I am supposed to have 2 on my red spinner and -3 on the blue spinner. So in order to get 2 on the blue spinner, it is 2 by 4, and here in order to get -3 I have 1 by 4. Do I have any more probability? I think I have 1 and -2. Yes, so 1 by 4 into 1 by 4. So in total we have, just a second, 2 by 16 plus 1 by 16, so which is 3 by 16, right? Now let us find out the probability of getting 0. Probability of getting 0 is 1 -1, 2 -2 and 3 -3. Okay. So probability of getting 1 and -1, 1 by 4 into 2 by 4 plus 2 and -2, 2 by 4 into 1 by 4 plus 3 and -3. So 1 by 4 into 1 by 4. I think this is 2 by 16, 2 by 16, 1 by 16. So total will be 5 by 16. Yes, total is going to be 5 by 16. Okay, so now let me find out probability of getting 2. How can I get 2? If I have 3 and -1. If I have 3 and -1. Okay, so probability of getting 2, let me find out. Probability of getting 2 is 3. So that is 1 by 4, and probability of getting -1 is 2 by 4. So the total probability is 2 by 16. Is there any more probability? No, I don't think so. So you have 2 by 16. Now let me add this. 5 plus 3, 8. 8 plus 2, 10. 10 plus 1, 11. Then probability of getting 1 is once again 5 by 16, right? So probability of getting 1 is once again 5 by 16. Let us move to the next question. Given that E of x is 0.25, find variance of x. E of x means mean is given to us and we are supposed to find variance. Okay, so we know variance is x square into p minus mean square. So -2 square is 4. So we have, for variance you have -2 square 4 into 1 by 16 plus -1 square, which is 1 into 3 by 16 plus 0 square is 0. So let us leave that number. 1 square is 1. 1 into 5 by 16 and 2 square is 4 into 2 by 16. 4 into 2 by 16. And from this we will subtract mean square, which is 0.25 square. So let me calculate this. I think this is 4 by 16 plus 3 by 16 plus 5 by 16 plus 8 by 16 minus 0.25 square. 4 plus 3 7, 7 plus 5 is 12, 12 plus 8 is 20. So you have 20 by 16 minus 0.25 square. Okay, so 20 by 16 minus 0.25 square, it is 19 by 16, or I can write this as 1.1875, and even 1.19 would do. Next question. In a certain country, the probability of more than 10 centimeter of rain on any particular day. पूरू वीडियो चालू कर दी तो पण सारू चलो. Question 2. In a certain country, the probability of more than 10 centimeter of rain on any particular day is 0.18 independently of the weather of any other day. Okay. Find the probability that in any randomly chosen 7-day period, more than 2 days have more than 10 centimeter of rain. So out of, in a period of 7 days, I have to find probability of raining more than 10 centimeter is from more than 2 days. So x greater than 2. This is binomial distribution. So I can find my 1 minus probability of 0 plus probability of 1 plus probability of 2, right? So probability of 0, using binomial distribution, you have 7C0, probability of success, which is probability of raining, 0.18, and probability of failure, 1 minus probability of success. Probability of 1 is going to be 7C1, 0.18, sorry, this is power 0. Sorry, my mistake. This is power 7 and this is power 0. So 0.18 power 7C1, 6, and 0.82 power 1. Oh, sorry, just a. Question 2. In a certain country, the probability of more than 10 centimeter of rain on any particular day is 0.18 independently of the weather on any other day. Find the probability that in any randomly chosen 7-day period, more than 2 days have more than 10 centimeter of rain. So we are supposed to find a probability x greater than 2 out of 7 days. I think it is pretty easy. 1 minus probability of 0 plus probability of 1 plus probability of 2, right? So using binomial distribution, 7C0, probability of success, power 0, and probability of failure, power 7, which is 1 minus 0.8. Probability of 1 is 7C1, probability of success, power probability of failure, and probability 7C2, probability of success power 2, probability of failure power 5. Make sure the total power is 7. So let me do that. 7C0 is I think 1. So 0.82 power 7 plus 7C1 is 7 into 0.18 into 0.82 power 6 plus 7C2 into 0.18 square into 0.82 power 5, and the total of all this is total of all this, which is probability of 0 plus probability of 1 plus probability of 2. The total of all this is 0.8845, right? And I am supposed to find greater than 2. So the final answer is going to be x greater than 2 is going to be 1 minus 0.8845. So 1 minus answer 0.1154. So the probability is 0.1154, or you can simply write 115, right? Next, for 3 randomly chosen 7-day periods, find the probability that exactly 2 of this period have at least 1 day with more than 10 centimeter of the rain. For 3 randomly chosen periods, find the probability that exactly 2 of this period have at least 1 day with more than 10 centimeter. So at least more, we are supposed to find 2 of this period have at least 1 day with more than 10 centimeter of rain. So first we are supposed to find x, which is greater than equals to 1, at least 1 day. So we can find 1 minus probability of 0. So it is pretty easy. Probability of 0 we already found out, 7c0, probability of success power 0, and probability of failure power 7. So this is 0.82 power 7, and 1 minus answer is 0.7507, right? So this is the probability of raining at least 1 day with more than 10 centimeter of rain. Now they have taken 3 randomly period, right? 3 randomly 7-day periods, and I am supposed to find that at least 2 of this period, sorry, not at least, exactly 2 of these periods, right? So it can be, let's say, on the first day, on the first period of 7 day it rains, on the second it doesn't, on the third it does. Similarly, first it doesn't, second it does, third it does. Similarly not, right? So on any 2 given days it rains, and on the third period it doesn't, and this whole will be multiplied with 3, right? Because you are not sure that on which of the 2 days. It could be like on the first day, on the first period it rains, second it doesn't, third it does. So let me do that. 0.7507 square into 1 minus 0.75, 1 minus 0.7507 into 3. So the final answer is 0.421. So the final answer is 0.421. Next question. At a summer camp, an arithmetic test is taken by 250 children. Okay. The time taken to the nearest minute to complete the test were recorded. Okay. The result are summarized in the table. Draw a histogram to represent this information. Okay. So we are supposed to draw a histogram, which means first we are supposed to find out frequency density, and then we are supposed to draw it. But guys, as this is histograms, we know the bars are connected, but here we have a gap, 1 to 30, then we have 31 to 45. So first let us reduce the gap. So how much is the gap? The gap is of 1 unit, right? And 1 divided by 2 is 0.5. So we'll add 0.5 to the lower class and subtract 0.5 from the lower class and add 0.5 to the higher class. So you have, let me just correct the values. So you have from 0.5 to 30.5. Here you have from 30.5 to 45.5. Here you have 45.5 to 65.5. Here 65.5 to 75.5, and at last you have 75.5 to 100.5, right? But as we are supposed to draw the frequency diagram, so we are histogram, so we are first supposed to find the frequency density, and we know frequency density is nothing but frequency upon class width. So let us find out frequency density of each of the respective bar. So the frequency is 21, class width is of 30 if I am not wrong. Yes, 30. So 21 upon 30 is 0.7. Next you have frequency is 30, class width is of 15. So the frequency density is of 2. Next you have 65.5 minus 45.5 is 20. Okay, so frequency is 68, class width is 20. 68 divided by 20 is 3.4. Next you have 86 is my frequency, class width is 10, so 8.6. And then we have, I think, frequency is 45 and class width is 25. So 45 divided by 25 is 1.8. See, these are my respective frequency density: 0.7, 2, 3.4, 8.6 and 1.8. And my graphs would be 0.5 to 30.5, 30.5 to 45.5 and so on. So using this frequency density and this time taken, I have drawn this bar graph over here. You can have a look and refer. Next, state which class contains the median. Which class contains the median? Okay, so median, how many students are there? We have 250 students. So the number of observations are even. So my median is going to be half of 250 is 125. And what comes after 125 is 126. So 125th data and 126th data are going to be my median. So let us find out where does this data lie. Let us find out this by cumulative frequency. This is 21, 21 plus 30, 51, 51 plus I have 68. 51 plus 68 is 119. 119 plus 86 is 205. So as you can clearly see, your 125th data and 126th data lies between 66 and 75. So your median class is between 66 and 75. Given that an estimate of the mean time is 61.05 minutes, state what feature of the distribution accounts for the median and mean being different. See, as you can see, they are saying that the mean is 61.05, but the median lies between 66 and 75. So why does such a huge difference, right? So the simple reason is, as you can see, the data is skewed, or I can say the data is not symmetrical. See, here the frequencies is very less, whereas from 46 to 65, 65 to 76 and 76 to 100, the frequency is quite high. So data is skewed or data is not symmetric. That is why such disparities amongst the median and mean. So we can write data is not symmetrical, or you can write data is skewed. Let's get to the next question. The weight of male leopards in a particular region are normally distributed with mean 55 and standard deviation 6 kg. Okay. Find the probability that a randomly chosen male leopard from this region weighs between 46 and 62. Okay. So we are supposed to find probability where Z lies between 62 and 46. Okay. So let me take this as Z1, which is x minus mu. We know the formula of Z is x minus mu upon sigma. So x, let's say 46 minus mu upon sigma, and Z2 is x minus mu upon, sorry, my mu is 55, not 52, upon sigma. So my Z1 is 46 minus 55, which is minus 9 divided by 6, minus 1.5 is my Z1, and my Z2 is 62 minus 55, divided by 6. 7 divided by 6 is 1.166. Okay. So see, this is my bell curve. This is my bell curve. Here is my 1.166, and on the negative side I have minus 1.5, and I am supposed to find out this probability. So what I am supposed to do, I am supposed to find out probability of Z2 less than 1.166, right, and then subtract it from this region. So using the distribution table 1.166, let us find out 1.166. So 1.166, let me just check, yes, 1.166. So 1.1, then you have 6 and then one more 6. It means add 12. So 0.8770 and you have to add 12, which is 0.8782. So this is my probability. Z2 less than is 0.8782. Let me write this down. Probability of Z2 is 0.8782. Now let us find out probability of Z less than minus 1.5. As you guys know, the value of negative is not possible. So what do? We flip the graph, right? The graph, we flip it something like this. And let's say this is 1.5, and we'll try to find out this region. So at 1.5 you have, let me find it out, 1.5, it is pretty real, we have 0.9332, right? 0.9332. But this 0.9332, this is my region, this is my 0.9332, but I am only supposed to find this region. So my final probability is going to be 0.8782 minus 1 minus 0.9332, right? So let me do the calculation. 1 minus 0.9332 and 0.8782 minus answer. So the final answer is 0.811. Next question. The weight of female leopards in this region are normally distributed. Just a second, guys. The weight of female leopards in this region are normally distributed with mean 42 and standard deviation of sigma kg. It is known that 25% of the female leopards in this region weigh less than 36 kg. So 25% weighs less than 36 kg. So you know 36 is obviously going to be on the left hand side because the probability is 25%, which is 0.25. So this much region is 0.25. I am supposed to find out sigma. So we know Z is equals to x minus mu upon sigma, right? Sorry, let us find out Z. We are supposed to find Z. We have 0.25. So first we'll have to find out what value of Z, for what value of Z we get probability of 0.25. Let us use the critical value table. If we have, we have. So see, this region was 0.25. It means this is obviously going to be of 0.75, right? So the critical value of Z of by the probability is 0.75 is 0.674, right? So my Z is 0.674, but it will be negative 674. Minus 0.674 is equals to x, which was 36, minus mu upon sigma. So my sigma is 36 minus 42 upon 0.674, negative 0.674. So let me do the calculation. 36 minus 42, 36 minus 42 whole divided by minus 0.674 is 8.9 8.902, or I can write it as 8.9 also. Let's move to the next question. Next question states, okay, the distribution of the weights of male and female leopard are independent of each other. Okay, a male and female leopard are chosen at random. Find the probability that both the weight of these leopards are less than 40 kg. So the male should also be less than 40 kg and the female should also be less than 46 kg. So basically probability of male less than 46 into probability of female weighing less than 46. First let us find out probability of male less than 46. I think I have already found that. Yes, see, we have already found out probability of female weighing less than 46. Less than 46 is minus 1.5, and I think we already got that answer as 1 minus 0.9332, right? So this is fixed, which is 1 minus 0.9332. Now let us find out probability of female weighing less than 46 kg. So probability of female, which is, we'll have to find out z is equals to x, which is 46 minus mu. What was the mean? The mean was mentioned to us in the given table in the above question. The mean was 42 and sigma is 8.9. So x minus mu upon 8.9. So 46 minus 42, which is 4. 4 divided by 8.9 is 0.449. So let us find out the probability of 0.449. So 0.449, 0.44, and we have 9, which means I have to add 32. So 0.6732. 0.6700 plus 32, pretty easy, 0.6732. So the probability of Z is 0.6732. So the final answer is 0.6732. 1 minus 0.9332 into 0.6732. So 1 minus 0.9332 is into 0.6732. 0449, or I can also write this as 045. Let's move to the next question. A group of 12 people consists of 3 boys, 4 girls and 5 adults. Okay. In how many ways a team of 5 people can be chosen from the group if exactly 1 adult is included? Okay, so we have to include only 1 adult. So out of 5 adult, only 1 will be included, and out of remaining 7 people, which is made up of 4 boys and 3 girls, I am supposed to select 4 guys. So 7C4 into 5, which is 175. Okay. Next question. Part B. In how many ways can a team of 5 people be chosen from the group if the team includes at least 2 boys and at least 1 girl? Okay, so let me write the option. We have 3 boys, 4 girls and 5 adults. Okay, so I need at least 2 boys. So let me write down the possibilities. I have 2 boys, let's say I have 1 girl, then I have 2 adults. 2 boys, 2 girls and 1 adult. 2 boys and we have 3 girls. 3 boys, 1 girl, 1 adult. 3 boys and 2 girls. I think these are the total possibilities. So for 2 boys we have 3C2 into 4C1 into 5C2. I think 3C2 is 3, if I am not wrong. 3C2 is 3 into 4 12 and 5C2 is 10. Okay, So this is 120. Then we have 3C2 into 4C2 into 5C1. 5C1 is 5, 5 into 3 is 15, and 4C2 into 15. The total is 90. Then 2 boys. So 3C2 into 4C3. 4C3 is 4, 3C2 is 3. 4 3s are 12. Here we have 3C3 into 4C1 into 5C1. 5C1 is 5, 4C1 is 4, 5 4s are 20. And 3 boys. So 3C3 into 4C2. 4C2 is, if I am not wrong, 6, and this is 1. Okay, 6. So let me add all of this. 120 plus 90 plus 12 plus 20 plus 6. So the total is 248. So the final answer is 248. Okay. Let's move to the next question or the next part. The same group of 12 people stand in a line. How many different arrangements are there in which 3 boys stand together and an adult is at the end of each line? Okay. So we have 12 people standing in the line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. We have 12 people standing in line, and at the end of the line we have adult. So adult and adult. So how many positions are the adults occupying? 2 positions. Any 2 adults will come out of 5. So 5p2, because here the position matters. That is why we have used permutation and not combination. And we have 3 boys which stands together. So let's say this is the first position of boy, then this is second, and this is third. They will act as a single unit. Wherever they'll go together. So I'll club them and I'll consider this as one unit. So I have 1, 2, 3, 4, 5, 6, 7, 8. So these 8 places can be arranged in 8 factorial ways. And I am taking 3 boys. So obviously this is 3 factorial, because boys also could be arranged. So 8 factorial, where's the sign of? Yes, 8 factorial into 3 factorial into 5p2, which is, the final answer is 4838400. Right? Very easy question which has 4 marks. Bonus question. A factory produces chocolates in 3 flavors: lemon, orange and strawberry, in the ratio 3:5:7 respectively. Okay. Nell checks the chocolates on the production line by choosing chocolates randomly one at a time. Okay. Find the probability that the first chocolate with lemon flavor that Nell chooses is the 7th chocolate that she checks. Okay. So first let us find out the probability of lemon flavored chocolate. I think we have 7 plus 3 10, 10 plus 5 is 15. So probability of lemon flavored chocolate is 3 by 15, which is 1 by 5. Now this happens on the 7th chocolate which she checks. So the first 6 chocolates are supposed to be orange or strawberry. So which is 4 by 5 power 6 into 1 by 5 power 1. So 4 by 5 power 6 into 1 by 5. So the final answer is 4096 upon 78125. Okay, next question. Find the probability that the first chocolate with the lemon flavor that Nell chooses is after she has checked at least 6 chocolates. Okay, so the first 6 chocolates are not supposed to be of lemon flavor. So obviously 4 by 5 power 6, pretty easy. So the final answer 4 by 5 power 6 is 4096 upon 15625. Next, surprise box of chocolates each contains 15 chocolates. 3 are lemon, 5 are orange and 7 are strawberry. Okay. Petra has a box of surprise chocolates. She chooses 3 chocolates at random from the box. She eats each chocolate before choosing the next one. Find the probability that none of the Petra's 3 chocolates has orange flavor. So none of them have orange flavor. Okay. So we know probability, desired outcome upon total outcome. So what is the total outcome? She is selecting 3 chocolates. So 15C3, right? And she is going to select 3 chocolates, but none of them are going to be orange. So out of the 10 chocolates she has, she will select 3. So 10C3 upon 15C3. Let me find out. 10C3 upon 15C3. The answer is 24 upon 91. Okay. Next part. Find the probability that each of the 3 chocolates have different flavor. Okay. So it of probability each has different flavor. So 15C3. Let's say the first flavor is of, I think strawberry. Was it strawberry, orange? What was it? Lemon, orange and strawberry. 3, 5, 7. We have lemon, orange, strawberry. 3, 5, 7. Let's say the first is of lemon flavored. So 3C1. Second is of orange flavor. 5C1. And third is of strawberry flavor. 7C1. So 3C1 into 5 into 7 divided by 15C3. This is 3 upon 13. Next question. Find the probability that at least 2 of the Petra's 3 chocolates have strawberry flavored, given that none of them has orange flavor. Okay. Probability that at least 2 have strawberry flavor, given that none is orange. Right. So I can find it out. Probability of at least 2 strawberry intersection, 2 being strawberry, at least 2 being strawberry and none being orange. Upon probability of none is orange. Right. Let us find out at least 2 being strawberry and none being orange. So we can have strawberry and the other flavor is, I think, lemon. Right. This will be multiplied with 3 because we can have strawberry, lemon, strawberry and lemon, strawberry, strawberry. So this probability into 3, and we can also have strawberry, strawberry, strawberry. So how many strawberries do we have? We have 7 strawberries. Okay. And 5 and 3 lemon. So let me write this. Let me find this probability first. So let's say first is probably strawberry, 7 by 15 into 6 by 14, and the third one being lemon, which is 3 by 13. This whole multiplied with 3. Right. Let me just solve this. 7 by 15 into 6 by 14 into 3 by 13 whole multiplied by 3. So this is 9 upon 65 and all 3 being strawberry. So 7 by 15 into 6 by 14 into 5 by 15 into, sorry, not 15, 5 by 13. This is 1 by 30. Right. So the final answer is 9 by 65 plus 1 by 13 whole divided by, none of them is orange. I think we have already found that. See, none of them being orange is 24 by 91 divided by 24 by 91. So 9 by 65 plus 1 by 13. This is 14 by 65 upon 24 by 91. 24 by 91. So the final answer is 49 upon 60. And I think with this we have completed the paper. Hope you have enjoyed it. Kindly share to our channel, subscribe it. Let us know if you need us to do revision on any of the topics. We are ready for you. Bye bye. Have a good day.